Okay, here we go. Now, does anybody celebrate a special day this past Sunday? So this past Sunday was a very special day. Tess,
Pi Day.
tell me what that means, Pi Day.
Um, like I don't really know.
So you heard, where did you hear about it?
Uh, well, from my mom.
Oh, great. Does anybody else know anything, Sabrina, Raymond, or Brennan? You know anything about Pi Day? Tess, go ahead.
My mom made a pie on Pi Day.
Oh, well, that is actually PIE. So
Yes.
the thing that we bake and that we eat is actually PIE. But what's kind of cool about it is that pies are usually in what shape, Raymond? Raymond, what shape is pie usually in? Raymond, can you hear me? Okay, Raymond, say
What
yes, I can.
pie? Which pie?
Any pie. Have you ever seen a pie baked?
The PIE pie is
Yes,
red.
yes. What is the shape of a PIE?
It's a circle.
Right. Now, is there a connection between the circle and the pie without the PIE? Yes?
It's not about that, but I know what number pi is.
Well, what number is pi?
3.14.
And what does that have to do with this past Sunday? Brennan,
That's the date.
hold on.
It's
Brennan,
the third month of the year, March, and then it's the 14th.
guys, it's March 14th. So it's the third month. So every time it's March 14th, we celebrate something called Pi Day. Now, let me show you about the symbol pi. The symbol pi looks like this. I want everybody to draw it on page 1, right next to Mr. Kramer's pie. So you're going to make one line going down, another line almost like an 11, and then a little squiggly that goes on top. So everybody show me their pie. Oh, nice. I see Brennan's. I don't see Raymond's, but I'm looking forward to it. Oh, I see Sabrina's. Nice job. Tess, I don't see yours yet, but I'll look forward to seeing your pie. And nice job, Sabrina. Very nice job. Now, I want you guys also to look at this symbol. Do you see that symbol right there on the right? Now, this symbol on the right is what you do on your computer. If you hit, like for instance, on a MacBook, if I hit Option and then P, the letter P, I get the pi symbol. It's a little bit different than the way the Greeks do it, but this is a Greek letter. It is a Greek letter. And I believe that it's the 19th Greek letter called pi. Now, do you know that pi has been around for 5,000 years? But it's only in the last 250 years that they actually called it pi. It used to be called, are you ready for this? It used to be called the quantity which when the diameter is multiplied by it yields the circumference. Is that a mouthful? Is that a mouthful?
Yes.
So they decided, this mathematician, a Welsh mathematician from Wales in 1706, said, you know what? I think we should call it pi, after the 19th Greek letter. And his name was William Jones. And then the symbol was made popular by another mathematician named Euler. So the symbol pi is very, very important. Now, I want everybody to go to page 2. Everybody go to page 2. Now, on page 2, I drew something called a unit square. Who can tell me the area of a unit square with a side length of 1? Go ahead, Brennan.
1 square unit.
Exactly. It's 1 square unit. Now, how many of that size square can fit inside what's called the unit circle, which has a radius of 1? By the way, everybody draw a circle under the square and draw themselves a dot in the middle and label it C for center. Then take your pencil and create a line which goes from the center to anywhere on the circle. And guys, you know what that's called? Can you guys say it out loud?
Radius.
It's called the radius. Whenever you go from the center of a circle to anywhere on this circle, it is called a radius. Now, the radius of a unit circle is 1. How many of these square units could fit inside if we smushed them together and they were all perfectly inside the circle? About how much do you think we would have? And oh, by the way, watch what I'm going to do now. I'm going to put another one and another one and another one to see if that helps. So if I said to you, the area of a unit circle, it must be less than what? The area of a unit circle must be less than how many square units? Raise your hand if you can see it. Come on, it's got to be less than what? 1, 2, 3, 4. Come on, it's got to be less than what?
7.
Come on, 1, 2, 3, 4. I just put 4 of those squares, and we know that the circle is smaller. So it is smaller than 4 square units. Now, who thinks they know how many exactly? If it's, what is a number smaller than 4?
3.
Yes. So do you think it's 3 or do you think it's more than 3?
More than 3, maybe like
More than
3.9 or something.
It could be 3.9, but it's not 3.9. It's definitely less than 4. It's definitely more than 3. And would you be interested to know that it is exactly 3.14 square units, which of course is
Pi.
pi. So the answer to the unit circle question is pi square units. Now, does anybody here know what the 0.14 really means? There's a lot of things that we could say about 0.14. Tess, what do you think 0.14 represents?
0.14.
That is the same. That's another way of saying 0.14. But what does it mean? It's the same as what? Does anybody know how to read decimals? This means, guys, 14 over 100. It's can you guys read it, please? 14 hundredths. So say 14 hundredths.
1400.
1400.
Hundredths. It's 14 hundredths, which, by the way, cut 14 in half.
7.
7.
Cut 100 in half.
50.
And guess what? 7/50ths is exactly the same as 0.14. Now, believe it or not, 7 goes into 50 about how many times? Come on, 7 times something is just less than 50. Who thinks they know? You know what? Let's count by sevens. Are you ready? Go. 7.
7. 14. 21. 28. 35.
35.
Still less than 50. Keep going.
42.
Still less than 50.
49.
Ah. So how many sevens make 49?
7.
Yay.
7.
So 7 times 7 is 49. So that means that 7 goes into 50 7 and a 7th times. And therefore, this number is very close to 1/7. So the fraction 1/7, write that down, is very close to 0.14. And now, underneath pi square units, we can also write 3 and 1/7. So everybody write that out. 3 and 1/7. Okay, did everybody do that?
Yep.
Okay, so we know that pi is a little more than 3. It's not quite 3.5. It's definitely not 4. And it's definitely not less than 3. Now, the next thing I want to do with you guys is I want you to look at another circle. If I said to you, how many arcs that look like this can fit around the circle? Don't say it out loud. How many of those arcs do you think I can fit around the perimeter of the circle? Raise your hand if you think you know. Raymond, raise your hand if you know. Raymond, come back here. Raise your hand if you know how many of those arcs can fit around the perimeter, the outside of a circle. Sabrina, raise your hand if you can see how many. Raymond, do you have any idea? Raymond, come back here. Come on, Raymond. Get back over there. Now, Raymond, stay with the program. Stay with the program. Okay, Sabrina, what do you think?
2.
Yes, and guys, watch this. If I clone this and then I spin it around, doesn't it fit perfectly right under here?
Yeah.
So we know that 2 half circles, right? So 2 half circles can equal the perimeter. Now, who knows what the perimeter of a circle is called? It's got a special name, perimeter of a circle, which is the outside. Who knows what that's called? Raymond, go for it.
I didn't raise my hand.
Okay, I thought you did. I thought you did. Does anybody else know? Now, I want everybody to please try to pronounce this word on 3. 1, hold on. 1, 2, 3, go.
Circumference.
So everybody go like this. Circumference.
Circumference.
Now,
Circumference.
you are holding something circular. I want you to put your finger along the circumference. And I want to see it. Everybody should have different circles right now. So I want to see that you are going around the circumference. Oh, I love it. Brennan, that's a cool one. And Tess, what's your circle?
Coin.
Cool. Oh, a coin. And Sabrina's is a plate. And Raymond, what's yours? A quarter? What is it, Raymond?
A quarter.
Cool, cool, cool. Now, I have a bigger challenge for you guys. You ready? What is it called when I take a line and I go from one side of the circle through the center all the way to the other side? Now, we already know that from the center, anywhere on the circle is called the what? Who remembers that?
Circumference.
No, no. From the
Perimeter.
center, no. From the center to anywhere on the circle has a special name. It is called a
Radius. Radius.
What is it called when we go from point A to point B right through the center? What is that called? Come on, it goes point A to point C. It's 2 radii. Does anybody know what it's called? It's called a diameter. Everybody write that down. Say diameter.
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 And if you take your plate and you take your pencil and you put your pencil right through the center, my pen right now is the diameter of my circle. It goes from one end of the circle all the way through the center to the other end. That's called a diameter. Now, here's the big challenge. You ready? How many of these red diameters can fit around the circumference of a circle? Don't say it out loud. Go to page 3 and start to sketch it. And then if you can tell me what you think, how many of these red diameters can fit in the perimeter or the circumference of a circle. So start sketching and start to see if you have an idea. And Brennan, why don't you label your diagram so you can show me? All right. So I want everybody to give me their conjectures. So let's start with you, Raymond. What do you think?
I didn't get anything.
Well, but what do you think, Raymond? Just remember, 2 half circles fit into the perimeter of a circle. How many diameters do you think we could draw around the circle? How many? What do you think?
2.
You think 2. Okay, so 2. And what do you think, Sabrina?
4.
4. And what do you think, Brennan?
I think 3.14.
Or could we just say pi?
Yeah.
And what do you think, Tess?
Hi.
Now, guys, let's not guess. Let's actually do it. So watch what I do here. And I think I'm going to take red. Would you agree that that looks to be about the length of the diameter when it's folded around the perimeter?
Yeah.
Yes or no? Yes?
Yes.
Okay, so that's 1. Raymond, that's 1. Now let's do the second one. Here we go. From that point, wait, I don't like that. That's not thick enough. I think that's a little thicker. Tell me when to stop.
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 And that looks to be 2 of them. So Raymond, there was a lot left over. Now, Sabrina, do you think that 2 more of these could fit in the remaining part?
No.
How many do you think?
I think 1 more could fit.
Yeah. And Raymond, what do you think?
Yeah.
And look at this, guys. That's the 3rd one. So 1, 1, and 1 make 3. But guess what's left over? Who can tell me what's left over?
Here.
Tess, look at that. How big is that going to be?
0.14.
That's going to be about 1/7. Because we should be able to put 1, 2, 3, 4, 5, 6, 7 of those around 1 diameter. So the answer is exactly pi diameters. So look at the bottom of your page where it says perimeter of a circle equals circumference, and the circumference equals pi diameters, or about 3 1/7. Now you should also know that when you take the circumference and you divide it by your diameter, you get also pi, which is approximately 3 1/7. Now, can you guys, did your parents give you a calculator to use to
Yeah.
a calculator available?
Yeah.
So if you have a calculator, I want you to go, wait a minute, hold on a second. I want to make sure I don't run out of battery here. Okay, so I want you guys to show me the calculator that you are using. I am using an iPhone calculator. Raymond, which one are you using?
Oh, I'm using my calculator to write on my computer. It's at the um bottom left corner.
Oh, interesting. Now, Tess, could you turn that sideways, please? There you go. If you turn it sideways, it should be a scientific. Now, how many of you see the pi button, which is going to be in the lower, the bottom row in the very middle of an iPhone? Hit the pi button if you can find it. Did anybody find it? You did? And let me ask you, oh my God. Wait a minute. Tess, don't move that. I'm going to take a picture of it. Move it a little closer to the screen, Tess. Little back, little back. That's good. Right there. Right there. Hold on. Got it. Got it. Okay. Now, everybody watch this. I just copied. Oh, no. It didn't work. Okay. Tess, do it one more time. Now, look at this, guys. Tess's calculator, and I didn't take the best picture ever. And I'm going to have to fix the first digit, which of course is 3. Now, everybody read it with me. Ready? 1, 2, 3, go. 3.
2.
Now, everybody stop right there. Now, when I did it on my calculator, okay, believe it or not, it stopped at the 3 because my calculator ran out of characters. It only went up to the 3. Now, guess what? Sir Isaac Newton. Have you guys heard of Sir Isaac Newton yet?
I was just reading about him.
So Sir Isaac Newton, who really discovered so many amazing things about gravity and created calculus. Sir Isaac Newton, he calculated that pi was equal to this number. He went to 16 digits after the decimal. Now, believe it or not, the Bible and the Chinese, 5,000 years ago, they thought that pi equaled 3. And they were close, but very far off. The Babylonians, they thought that pi was 3 1/8. So didn't they get way closer?
Yeah.
But still kind of
But
far away.
still kind of off. Now, it's really, really cool. Now, by the way, this is my calculator, and it only goes up to 15 digits. But Sir Isaac Newton, he went up to 16 digits. Now, what's even better than that? That was 1665. You can look at page 4. Isaac Newton, he calculated the most digits of pi up to that time. Now, in the early 1700s, about 50 years later, a guy named Thomas Lagney, he calculated 127 decimals, reaching a new record. And then, believe it or not, it increased to 2,000 digits. And then in 500,000 digits around 1950 using a computer called CDC 6600. It was one of the first computers ever made, and it calculated pi to 500,000 digits. Now, that is nothing compared to what happened 4 years ago. Are you guys sitting down?
Yes.
4 years ago, a Swiss mathematician, Raymond, look up. Raymond, look up. A Swiss mathematician, he calculated 22 trillion digits of pi. That calculation took him over 100 days using just regular computers. Pretty amazing. Tess, I love that number. Now, let's look at something else. What I want you guys to do right now, does everybody have a ruler or a measuring tape? Mr. Kramer has this measuring tape right here, which does both inches and centimeters. Raymond, tell me what you've got to use.
I don't have a ruler.
Could you please go ask your mom for a ruler? We need you to have a ruler. Okay, go ask her.
My mom's at work.
Is there any adult that would be home right now?
Oh, my grandma's home, but she doesn't know a lot of things about the house.
So she would not know where a ruler is?
She never knows where.
And would you
Anything
know
is.
where you keep your supplies, like mathematical supplies, maybe markers and things like, and pencils? That's usually where the rulers are kept. Now, Tess, let me see your ruler.
Okay, I have a small.
Good. Oh, there you go. You see, Raymond, when you look, Raymond, amazing things happen. Sabrina? Now, Raymond, does your ruler show, Raymond, look me in the eyes. Does your ruler show centimeters and inches?
It shows it, but it broke in half.
Okay, you can use one of the halves. Raymond, does
Well, I
it
have
show,
one half.
Raymond, does it show centimeters or does it show inches or does it show both? And I'm going to ask that question.
It shows both.
Okay, great.
Even though the inches starts from 0, but the centimeters, the smallest one is 16.
Okay, and Brennan, what about yours?
Yeah, mine shows both inches and centimeters.
And what about yours, Tess?
Inches and centimeters.
You have to speak up, honey.
Inches and centimeters.
And Sabrina, what about yours?
I'm still looking for one.
Okay, so you do not have a ruler.
Yeah, I'm gonna go ask my nanny.
Can you go do that now? Now, guys, I want you to all show me a circle that you have prepared for today's class. So my first circle that I prepared was a plate that I used to put tea and coffee on. And it's a really nice circle. And there's also a circle within the circle, which is kind of cool. Now, I want everybody to take their ruler and put it across the diameter of your circle. So I want you to see how Mr. Kramer is putting his measuring tape, and then I'm going to mark the end of it. And do you see how this is the same as my diameter? And then I'm going to read it. So Mr. Kramer's diameter was, and I think it's better to do in centimeters. Sabrina, did you find one?
Yeah.
Okay, great. So Sabrina, I want you to take a circle that you prepared and measure the diameter, which is the distance across from one side to the other through the center. Now, hold on a second. Everybody now, please go to page 7 in their packet. Go to page 7. Now, I want you to write down the word in the description, the word plate, because it's Mr. Kramer's plate. So you can even say K plate for Kramer's plate. And then I want you to write down 14 centimeters. Has everybody written that down?
Mm-hmm.
Now, here's what we have to do. We now know that there are pi diameters in every circumference. So we have to take our diameter, in my case, it's 14 centimeters, and I have to multiply it by about 3 1/7. Now, what I'm going to do is I'm first going to do 14 times 3, and then I'm going to do 14 times 1/7. Now, who thinks they can put 14 over 14 over 14 on their page and add up the 3 14s? Don't say your answer, but write it down. Write them vertically right now. Come on. 14 over 14 over 14. Raymond, go ahead and write it. Go ahead and write it, buddy. And then, if you add 4 plus 4 plus 4, you get what?
12.
And you carry the 1 in the tens place, and 1 plus 1 plus 1 plus 1 is?
40.
So therefore, it's?
42.
And now, who knows what happens if I take 14 times a 7? So I have to split 14 into 7 equal pieces. What is 14 divided by 7? Raise your hand if you know. Raise your hand if you know. How many times does 7 go into 14?
2 exactly.
It's exactly 2. So guys, you have to add 42 plus 2. And what do we get?
44. 44.
So my conjecture, my guess is that we're going to have 44 centimeters for my circumference. So everybody go back to the chart and write 44 centimeters. Now, this is the fun part. The fun part is, and it's kind of hard to do, I am going to put the plate on my table. I'm going to turn my screen down, and I'm going to use my measuring tape to measure the circumference. Now, if you don't have a flexible measuring tape, you may have to use like a phone cord or some sort of a piece of string. It's not so easy to do. Now let's see. I wasn't successful the first time. I'm gonna try it again by opening this up a little bit more. And I'm gonna roll it around. Oh, wait a minute. Guess what? I picked the wrong plate. That's why it wasn't working. So if I put this plate down and I go around the plate, oh my God, you would not believe, guys, exactly 44 centimeters. Everybody look at it. Exactly 44 centimeters. Now that means I'm going to record that in the actual circumference, the actual perimeter. Now, I'm going to go with Tess first. Tess, what was the object that you chose to use for today?
A coin.
What kind of a coin?
A $1 coin.
Wow. So you have a dollar coin. And Tess, when you do the dollar coin, you may actually have to do it in millimeters, which are the little tiny sections inside every centimeter. Do you see the millimeters?
No, but I know how many centimeters is it.
Well,
It
how
is
many centimeters is it?
2.5.
Ah, so everybody write down dollar coin and then 2.5 centimeters. Now, this is going to be a little challenging, but I love that. That's my favorite thing to do. So let's take 2.5 and we're going to multiply it by 3 1/7. So the first thing we have to do is we have to multiply 2.5 by 3. Now, who can add, write it down, 2.5 plus 2.5 plus 2.5. Now raise your hand if you know the answer, but don't say it out loud. Raymond and Sabrina, do you have it yet?
No, not yet.
You getting there? Raymond, what about you, buddy? I don't see you writing it down.
Writing.
If you don't write it down, it's really hard. All right, guys, on 3. 1, 2, 3.
7.5.
And
Wow. Now, guess what? We also have to take 1/7 of 2.5. Now that's going to be kind of hard to do. But remember, guys, 2.5 is approximately 5 halves. I mean, it is equal to 5 halves. So if I have 5 halves, then 1/7 of that is approximately a little bit smaller than 1/2. So everybody, let's add a half to the 7.5. And what do we get? Sabrina, 7.5 plus a half is what?
8.
You got it. Now, Tess, I want you to take your string or cord and measure around the circumference of the dollar coin to see if in fact it is 8 centimeters. So 8 centimeters is our conjecture. I think it should be a little bit less than that. So Tess, were you able to do your measurement?
I'm doing it right now.
Okay. And while she's doing that, Brennan, can you give me your object?
It was the exact same as yours, 14.
Say again?
Mine's a plate and it was the exact same as yours, 14 centimeters.
Wow, that's pretty cool. Brennan, do you have any other objects?
Yeah, I have a
Well, go ahead, man. And
I have a
go ahead and measure it. And Raymond, what do you have? How about you, Sabrina?
wait, what?
You need to show me the circle you've chosen, and then I want you to give us your diameter. Okay, so that is a Sabrina plate. And Sabrina, could you please measure the diameter of your plate? And Raymond, what is your object?
I have a gold coin.
You have and what is yours is a quarter, right?
Yes.
All right, so Raymond, what is the diameter of your quarter? Sabrina, what is the diameter of your plate? Brennan, what's your object?
It's a bowl and what is the next? It's just about 8.9 inches.
Oh, can you do it in centimeters?
I mean, sorry, 8.9 centimeters.
Okay, so instead of saying 8.9, what do you think would be a good estimate?
Like, no, well, actually 8.
Wait, you think it's closer to 8 than it is to 9?
And no, I mean, I remeasured it and it was actually 8.
Ah, 8 centimeters. Okay. Now, Tess, did you come up with your circumference for your dollar coin?
8.5.
Wow. Everybody write that down. The actual measurement was 8.5. So when Tess measured her diameter, maybe was a little more than 2.5 centimeters. Okay, very, very good. Now, Sabrina or Raymond, can you tell me the diameters of your plate and quarter, respectively?
My quarter is 4.5.
Your diameter, the diameter of your quarter is 4.5 centimeters?
Yes.
I don't think so, unless the dollar coin was not 2.5. Raymond, show me the diameter. The diameter goes from one end right through the center to the other end. And measure it again. Come on, put your measuring.
I'll measure it as 3.5 centimeters.
Okay, say again.
3.5 centimeters.
Wow. Now, Tess, isn't a dollar coin bigger than a quarter? So Raymond, your quarter must be smaller than 2.5 centimeters for diameter.
No, it's not really a quarter.
Oh, buddy, what is it?
It's actually a gold coin.
Oh, it's a gold coin. Okay, so it is a gold, thank you, coin. And tell me what it was. You said it was 4 centimeters.
It's 3.5.
Well, we're gonna go, well, you know what? If it's 3.5, we're gonna go with 3.5. And Sabrina,
Yes.
what about yours?
Mine is 25 centimeters.
Yours is 25?
Mm-hmm.
Okay. Now, everybody, I think we should do Sabrina's plate first. Everybody look, we've got to do 25 times 3 and a 7th. So raise your hand if you know 25 times 3. In fact, if you know how to count money, you should know 25 plus 25 plus 25. It's a really important number to know. On 3, 1, 2, 3.
75.
75.
And then how many 7s divide into 25? How many 7s divide into 25? Anybody know? Let's count the 7s. 7, 14, 21. So it's 3 and 4/7. So everybody, let's add 75 plus 3 and 4/7. Who thinks they have the answer? 75 plus 3 and 4/7 on 3. 1, 2, 3, go. Come on, guys. 75 plus 3
78.
78.
and 4/7. So everybody write down 78 and 4/7 centimeters. And now, Sabrina, can you measure your circumference, please? Okay. Now, everybody now, while we're waiting for Sabrina, everybody do Raymond's 3.5 times 3 plus a 7th, which is pi. Who knows what 3.5 times 3 is?
No. 9.5.
Not 9.5. 3.5, 3.5, and 3.5 equals 9 plus 1.5, which equals
10.5.
10.5. And then a 7th of 3 is about a half. So now let's add a half to 10.5. And what do we get, guys? Go. Go, say it. 10.5 plus a half.
11.
So everybody write down as a conjecture 11 centimeters, and go ahead, Raymond, test the circumference of your gold coin right now. You have to pick up a string or a measuring tape that's flexible or a iPhone cord. Now, the next thing we're going to do, guys, is we have to multiply 8 times 3 and a 7th. Now, come on. Who knows 8 times 3?
24.
And who knows how many 7s go into 8?
1.
Just about 1. So everybody, 24 plus 20 plus 1 is?
5. 25.
So everybody write down 25 centimeters. And I want Brennan to be testing his circumference.
Yeah, my flexible measuring tape doesn't do centimeters.
Oh, that's too bad. So why don't you then, that's too bad. That's too bad. Let me just think about this. Oh, I got it. Why don't you measure, look at me, Brennan, measure the circumference with the flexible, but then put it up against the centimeter.
Okay.
Okay. Now, I'm looking for Sabrina. I'm looking for,
So actually, I should just do it in inches and then multiply it by 2 since there are 2 centimeters in each inch.
well, Brennan, I have to tell you, that is a beautiful conversion. It's very close. There's about 2.5 centimeters in every inch, but don't do that. Just take the measuring tape and just use it as if it were just string.
Oh, wait, now
And put
never
it,
mind, I found the centimeter side.
okay, good man. Does Sabrina or Raymond or Brennan have their circumference? So I want you guys to work on this week, and I want you to calculate as many of these as you can in your house. I bet there are hundreds of circles. Raymond, do you have an answer for me?
Your conjecture is right.
I can't hear you.
Your conjecture is right.
Wow, it was 11 centimeters. Awesome. Awesome, awesome, awesome. I'm so excited. And what about you, Brennan?
Still measuring.
And what about you, Sabrina?
Mine is 78.47 centimeters. So it's the same as we did.
Oh, you got 78?
And 4 cents.
Wow, that is so cool. Now, I'm amazed that you guys were able to do as well as you did, because that's the way ancient mathematicians figured out pi. And Brennan, this
No.
buddy?
37.
Wow. So guess what, Brennan? We were off by a lot. We were off by a lot. So that means that it must not have been 8 centimeters. So I want you to go back to the drawing board and see if you could figure it out. Guys, I've got to say goodbye now. We're out of time. Everybody did such a great job. Please give a big wave to everybody and say Happy Pi Day. Hold up your circle.
Happy Pi Day.
Pi Day.
Happy Pi Day.
All right, guys. Bye.